Hello. Welcome again. And today we're going to be, as I promised last week, going through the rest of these sheets and kind of telling you some of the answers. If you have not had a chance to complete these yet, please don't watch right now. I don't think anybody is here at the moment, but if you haven't finished these, just come back and watch this video later. It'll be saved to YouTube, so you can always access it. It is always more helpful for learning the material if you go through stuff on your own, even if you don't do it right the first time, rather than just copying the answers as I go. All right. So, oh, and in case it didn't come through properly in the title stuff, this is for Chem 103, not Chem 100. All right. So most of this stuff, as we talked about last time, you can, the questions like these critical thinking questions are really just meant to help you to figure out what's going on. And the real like testing yourself part is where you get to these exercises. All right, so with these, what we're doing here is we're looking at these molecules and we're trying to see like how many of each type of atom is there. So we can see in this one, so the darker spheres are going to be carbon, the lighter ones are oxygen, and the smallest ones are hydrogen. So in this molecule, I see 2 carbons, I see 1 oxygen, and I see 1, 2, 3, 4, 5, 6 hydrogen. So I'm going to write that formula C2H6O. Now the order that you put those letters in, C, H, and O, doesn't technically matter. Generally, a rule of thumb is it goes C, H, O, but you don't have to do it that way. If you did it C2OH6, or if you did OH6C2, that's technically all fine. All right, so you can probably figure those out. So this bottom one here has more oxygens, right? So this would be a C3H4O3. And this is just another, like, kind of the backwards practice of that. Can you look at a formula and figure out how many of each atom are there? I think you can probably do that. All right, let's look at this part that I said was kind of the overall goal of this. And now that everybody's had a chance to do lab, you should have a little bit better sense of how this works. So you want to categorize things first as either a pure substance or a mixture, and then the subcategories of those things. If it's a pure substance, it's either an element or a compound. If it's a mixture, it's either a heterogeneous mixture or a homogeneous mixture. All right, so a lead weight. Well, a lead weight, the key word here is lead. Lead is an element. It's in the periodic table. It's right behind my head, right there, lead, Pb. So that's going to be a pure substance, and it's going to be an element. All right. Apple juice. Apple juice, is that a pure substance? No, it's a mixture, right? Think about all the things that are in apple juice. You've got sugar, you've got water, you've got flavorings, colors, all that kind of stuff. So it's definitely a mixture. And then is it homogeneous or heterogeneous? Well, I guess it technically depends on your apple juice. Some apple juice, if you're thinking about apple juice the way I am, the clear yellowish stuff that you can see through, because it's translucent, you don't see any particles floating around in it. That really makes it a solution, which makes it a homogeneous mixture. But these things aren't always that straightforward. So if you think of apple juice as like apple cider, where it's kind of more, there's sediment, it's like freshly pressed from the apples and you can see little bits of stuff. Maybe you think of that more as a heterogeneous mixture. Not all of these have a totally clear answer like that, particularly the mixtures. Baking soda, the key here, or the clue for you there, is that the chemical formula is given. So this is saying it is one type of chemical thing, and that is called a compound. So this is a pure substance, and it is a compound. Because that formula is given, that's telling us that those elements are bound together chemically. and that makes it a pure substance, but a chemical compound. And then we've got air. Air is not a pure substance. Air is a mixture. If you don't know some of what these things are, like air or like these different types of gold, please look them up so you have a sense of what that is. But air is a mixture of many gases, predominantly nitrogen. That's the largest component of air. But then there's also oxygen, there's carbon dioxide, there's water vapor. And so the mixture. And then is it heterogeneous or homogeneous? Well, if you think about the distribution of gases around you in the air, there are not particular different like spots with different types of gases. So you don't have like oxygen in this corner and nitrogen over here and oxygen over there. It's all mixed evenly. It's all distributed evenly. And so that makes it homogeneous. All right. And then you can try out some of the rest of these. With this gold business, if you don't know those definitions, you can look them up. But 24 karat gold is pure gold. So that would be a pure substance and an element. 14 karat gold is gold that has been mixed, alloyed with other metals, particularly silver. So that makes it a mixture. But if you look at 14 karat gold, that's what a lot of jewelry is made of. You don't see like gold bits and silver bits. It's all mixed evenly together. And so that makes it a homogeneous mixture. All right, and then see if you can figure out the rest of these. And so our first quiz will have some of this kind of stuff on there where you have to pick if the stuff, which category that stuff fits into. All right, I also want to look at, I think you can do this drawing part on number 4. I do want to look at number 5 here. Which of the choices would best represent the 3 molecules you drew? So you're drawing 3 water molecules. I guess we do kind of have to draw them. So 3 water molecules. Water is H2O. Ball and stick means you can either use the actual balls or you can use the letters. I guess since we used the balls earlier, we'll stick to that. So oxygen is bigger than hydrogen. So we might do something like that. So there's one. There's another one. And there's the third one. All right, so 3 water molecules. Inside is the oxygen, and these are the hydrogens over there. You can do it with letters too. All right, so then which of the choices best represents? So these are 2 different ways of representing this formula. But one of them says H6O3 and the other one is 3H2O. And which one is better? Well, you might have a feeling that the second one is better because you know that water is H2O, and you'd be right, but let's think about why. When we put a formula together like this, H6O3, what we're really saying is that is one molecule, one substance, one compound with 3 oxygen atoms and 6 hydrogen atoms connected together some way. So you can imagine like 3 oxygen atoms connected together with hydrogens coming off of them or something. And that is not water. That is some other compound. I don't think it exists. That is something else. So when we have a chemical formula like H2O, that's identifying our compound as a single thing with an oxygen and 2 hydrogens. And then the 3 in front of it is telling us that there are 3 of them. So that's the right way to express 3 water molecules. All right, if you have any questions about those or it's not clear, just send me a message, let me know. Or if you're following along right now, you can ask. You can also ask in lab if you're whichever group you're in. All right, so I want to move on now to the other one. So we talked a little bit about how to get started with this and how to count these particles. So let's move down to where I've got the star here and see how we can fill in a table like this using that knowledge. Again, if you haven't done this yet, please work through the packet first and then come back to this after you've tried this out on your own. All right. So the first one, we're just given a symbol, K and 40 in the upper left-hand corner. And from the rest of this worksheet, we know that The symbol tells us the type of atom that it is, and we can look that up on the periodic table and get the atomic number. And we know that this little number in the upper left-hand corner is called the mass number, and that is a measure of the mass as given by counting the protons and neutrons. So the total number of protons and neutrons gives us that number. So let's look up potassium on our periodic table, and you'll see it is all the way over to the left, number 19. And we also know from the packet that that atomic number of 19 tells us that there are 19 protons as well. Okay. So what else do we know from this? Well, we know that the 40 over in the upper left-hand corner, that's the mass number. And we know that the mass number is always the protons plus the neutrons. So the number of protons, the number of neutrons. We know the number of protons. We know the mass number. So we can get the number of neutrons just by subtracting. 40 minus 19 is 21. Now for our final spot, the number of electrons, we need to know the charge on this atom. And there is no charge given, so we know that we assume it's neutral. A neutrally charged atom means that there are the same number of protons, which are positively charged, and electrons, which are negatively charged. So we've got the same number of each. We know the number of protons, so we also know the number of electrons because they have to be the same number. So we've got 19 protons and 19 electrons. Sound good? Great. Okay, so let's move on. The next one kind of goes a little bit backwards from that. We're given the number of each particle, and we are not given the atomic number or the mass number or the symbol. So we have to figure that out. But all the same rules still apply. So the number of protons corresponds to the atomic number. Those are always the same. The mass number is the protons and the neutrons added together. So 15 plus 17 is 32. And then we can get the symbol by looking up the periodic table, atomic number 15. So that is right up here. That is phosphorus, number 15. All right, now we just need to put that mass number in the upper left-hand corner, so 32. And then we're not quite done. Don't forget the charge. The charge here, we have to figure that out. We look at the protons and the electrons. If they have the same number, the charge is 0. It's neutral. If they don't, they have a different charge. So here we've got 15 protons and 18 electrons. 3 more electrons, which are negatively charged, than protons, which are positively charged. So if we have 3 more negative charges, then we've got a 3 minus charge here. So we don't want to forget that. Okay, moving on to the next one then. We've got zinc with a 2 plus charge, and the number of neutrons is given over here. So the atomic number we can look up on the periodic table. Zinc is right there. That is number 30. And that tells us we have 30 protons. Now be careful here. To get the mass number, remember the mass number is the protons and the neutrons. It is not the number that's given on the periodic table right there. That is the average atomic mass. You'll notice it's a decimal number. That is not the mass number. And so we don't get that from the periodic table. We get that from adding the protons and the neutrons. So 30 protons, 38 neutrons, that is 68 altogether. So we can put a little 68 up in the corner there. And then for the number of electrons, we look over at the charge and we see that this zinc has a charge of +2. So that tells us that we need fewer electrons than protons. We can't change the number of protons because that would change the element. But we can change the number of electrons and go from 30 to 28. We have fewer electrons there. All right, and then the final one, atomic number 35, tells us there are 35 protons. Mass number of 81, the difference between these two is going to be our number of neutrons. So 81 minus 35 is 46. We can look up number 35 on the periodic table, which is right here, bromine. And that's going to be bromine 81, the mass number. And then our last step is to add that charge, if there is one. We've got 35 protons, 36 electrons, so that makes a -1 charge on the bromine. All right, and the rest of these are pretty simple to look up. So that's this. Now remember, the point of this whole activity is so that you learn how to do this. I'm not going through these worksheets and checking that you got every one of these things right. So it's to your advantage to do it on your own and figure it out rather than just copying what I did. Make sure you can do this because we are going to do a quiz where you will have to do this. Okay, as usual, let me know if you have any questions, and I will see you in lab, or half of you in lab, on Wednesday. Bye, everybody.